Hi everybody, welcome to Chapter 10. You finally made it. This is the very last unit of the year. We're skipping 10.1.1, going straight into 10.2.1. Today's lesson is about rewriting equations to make things easier to solve. So our goal for today is exactly that, where you're going to get a complicated equation and you're going to try to manipulate it somehow to make it easier for you to solve. Okay, so the EQ today is how can I solve it, right? There's always more than one way to solve problems in algebra, but there's usually the easier way, or the easiest way sometimes, or most of the time actually. So let's jump right into this. It says you've solved linear, quadratic, and exponential equations in this course. Sometimes when an equation looks very complicated, it can be rewritten before being solved to make the solving process easier. 10-22, Cassie wants to use the zero product property to find the x-intercepts with this quadratic function. So if you recall, the zero product property is when you factor it, and you're going to get two binomials and set them equal to 0. And then once you factor it, you'll set each binomial equal to 0, and you'll solve for x, and you'll get two separate answers. Right? So suddenly, Claudia blurted out, "No, Cassie, I think there's another way. Can't you first rewrite this equation so that it has no decimals? Then it will be faster and easier to factor, and we won't have to use a quadratic formula." What is Claudia talking about? Explain what she means. Then rewrite this equation so that it has no decimals. Okay, so I want you guys to pause the video right now and see what you can do to this equation right there. Okay, how can you manipulate that equation so that it's going to be easier to solve? And once you do that, go ahead and solve it. Okay, so remember when you're solving it, you're factoring it out of the way and you're solving for x. Okay. Alright, so you should have, hopefully you either multiply the entire equation by 2, like I did here, because I know 1.5 and negative 2.5, if I multiply it by 2, I'll get integers. The other option was maybe if you could have decided to multiply everything by 10, would have gotten rid of that decimal as well. Okay. So once I multiplied everything by 2, as you see there, I was able to factor it, right? My factors of negative 10, a times c, that 2 times the negative 5 got me that negative 10, and I factored it, and it gave me a 5 and a negative 2 that will add up to my middle term of 3x. Then I put it in the generic rectangle, and I factored, and I got x minus 1 and then 2x plus 5. So if I have x minus 1 equals 0, and then 2x plus 5 equals 0, I'm going to get x equals 1, and then x equals negative 5 halves. Okay? Alright, let's move on to the next question. 10-23, it's challenging you again to rewrite these problems before you actually start solving them. Okay, so I want you guys to do what you think you can do for A, B, C, and D, so that you can make life easier on yourself before you actually start solving the equation. Okay, once you do that, go ahead and solve the equation. Pause the video. Why don't you guys do A right now? Pause the video, come back, and see what we get. Okay, so for A, hopefully you identified that you could have gotten rid of that 32. That's multiplying each one of those terms by dividing everything by 32. And you get this equation right there, that 3x minus 5 equals 7, and it's essentially a two-step equation from that point on. Okay, go ahead and pause the video and see what you come up for B. Okay, you should have determined that everything was divisible. The greatest common factor is going to be 3,000 between the three terms on the left there, and so you divide everything by 3,000, including 0. 0 divided by 3,000 is still 0. And then I solved this way. I just decided to use the quadratic formula for this one, and I got 5/3 and negative 1. Okay. Go ahead and pause the videos at this point. Just do C and D. Alright, so for C that should have been super quick. Multiplied everything by your common denominator of 3, and it'll essentially, it's what we call fraction busters or fraction blasters. You're getting rid of the denominators in your fraction. And then for problem D, if you multiplied everything by 2, you would have gotten rid of that decimal of 2.5, made it a negative 5 instead. And here I factored, and I got negative 5 halves and positive 1 half. Okay. Let's take a look at 10-24. It says Derek and Donovan were trying to solve the equation 4 to the 4th times, or excuse me, 4 to the 4th equals 16 to the x. Derek had an idea. Okay, so this is a very important problem. Because the previous problems you basically applied what you knew already to how to solve a problem you were already familiar with. However, this part, for the majority of you guys, you haven't really seen a problem like this before. At least I don't recall doing so in class. So, Derek's idea said, as I know, isn't 16 equal to 4 squared? Yeah, so what? Said Donovan. Well, that means that we can rewrite the equation to look like 4 to the 4th equals 4 squared to the x. Okay, so essentially, 4 to the 4th is right there, right? It's the same thing. But if you notice, that 16, he's just rewriting it so that it becomes 4 to the 2nd, 4 squared. So he said this is much easier to solve. Okay, so take a look at that. If you've got 4 to the 4th equals 4 to the 2nd to the x, well, recall at one point a while back when we talked about logs briefly, logarithms. But I said if things are the same base, okay, they both have a base of 4, we can just basically ignore it and say the exponents are equal. Okay, this is certainly true. It has to be true, because if we're saying, both of those, 4 to the 4th is equivalent, it's equal to 4 to the 2x, well, we're saying 2x has to be the same as 4, because these two are equal to each other, right? And so if we say 2x equals 4, it's super easy to solve. So, yes, said Donovan, that makes sense. Is there another way too? Since 4 is the same as 2 squared and 16 is the same as 2 to the 4th, can't we rewrite it this way? Okay, so will both methods work? Well, I'm telling you, they absolutely will work. All right, let's solve this. So I'm going to solve this for you guys, and then you're going to practice it with the next few problems, okay? So it says use both methods to solve this. So I'm going to solve the first method, okay? So this one right there. Again, if they're the same base, it has to be equal to each other, because we're saying this left side is equal to this right side. So both 4's are the same. That means the exponents have to be the same. So it's essentially we just ignore the bases, and we'll say 4 equals 2x, divide both sides by 2, x equals 2. Okay, so there's our first way of doing it. And then Donovan's way is he changed that 4 to a 2 to the 2nd power, and he changed the 16 to 2 to the 4th. And he's saying, well, can't we solve it that way? Absolutely. Right, so again, if the bases are both the same, that means the exponents have to be the same as well. So recall that if I have something raised to another power, the rule there is that we're going to multiply. So 2 times 4 is 8, and 8 equals 4 times x, which is 4x. Divide both sides by 2, and we're going to get x equals 2. Excuse me, divide both sides by 4. X equals 2. So, same answer, same thing. Okay, so why don't you guys pause the video. I want you guys to attempt problem C here. See what you guys can come up with for that. Rewrite one of those numbers. Okay, so hopefully you rewrote it in the 9 You rewrote the 9 as 3 to the second power, okay, because 3 squared is 9, right? So now, if I have the same base of 3's, I can ignore the 3's. I have my exponent was 5, equals, well, I have 2 raised to another power of 2x should be 4x. And so I divide both sides by 4. X is going to equal 5/4. Okay. So this is a really handy trick for you guys to keep in your back pocket. You will definitely see a lot more of this once you get to Algebra 2. Okay, let's go to 10-25. These actually, we're going to end the lesson with this problem. So we're not going to do 10-26, but for 10-25, I want you guys to pause the video and attempt problem A for now. Okay, we'll do problem A together, and then we'll pause. I guess we'll do the next 3 one at a time. Okay. Okay, so A is pretty straightforward. They both have a base of 2. So we can ignore the bases and say that x plus 3 equals 2x. And we just subtract x on both sides. So therefore 3 equals x, or x equals 3. Okay, once you guys try problem B, see what you guys get for problem B. So this one is straightforward as well. And for problem B, if the base, the problem has both sides have a base of 3, ignore the bases, we get 2x plus 1 equals 3. Okay. At this point, why don't you guys just try C and D? So A and B are very straightforward, right? We didn't have to manipulate any of those bases, but once you get to C and D, it's a little bit trickier. So can you guys see what you come up with for C and D? Pause the video, come back when you're done. Okay, so here are our last 2 problems. For part C, you just change 9 to 3 to the second power, and so therefore you get 2x equals 40, and then x equals 20. For problem D, you change 8 to 2 to the third, so essentially you have 3 to the 70th power, you're going to get 210. So 2 raised to the third to the 70th. 3 times 70 is 210. So you ignore the bases of 2 and you get 210 equals x. Okay, so that is it, guys. That's all I have for you today. However, I do want to leave you with one challenge problem. Okay, I'm not going to give the answer at the end, but I want you guys to try it, and maybe I'll post it in the next video, or I'll post it on the Haiku page what the answer is. All right. Let me write this down. Give me 1 second. Okay, there is your challenge problem for the day. If you can do this problem, you should have a pretty solid understanding of today's lesson, or the second half of today's lesson at least. Alright, that's a wrap, guys. Hope you guys have a great day. Don't forget to email me if you have any questions, set up an appointment with me, and hope you all are doing well. Alright, take care, guys. See ya.